Hello students, today I'm going to take class 10th topic, that is light, and in this chapter you have to study only two laws. One is the law of reflection and second is the law of refraction. In this chapter some of the students find some difficulties regarding sign conventions and ray diagrams and in numericals also, and some difficulties are related to where to take positive sign, where to take negative sign, and some numericals. In some of the numericals they find some difficulties like magnification and some other terms, like they are difficult for students, but they are not difficult at all. And whenever you are doing ray diagrams, whenever you're doing numericals, you have to deal with the law of reflection only. So what is law of reflection? First, what is reflection? When the ray of light strikes with any of the obstacle, it will come back in the same medium. This is reflection, and we are able to see the things around us because of the reflection. And what are the laws of reflection? Incident ray, the ray between the angle of incidence, the angle between incident ray and normal, and angle of reflection, the angle between reflected ray and normal. Both of the angles are equal. So angle of incidence is equal to angle of reflection. And second law is the incident ray, normal and reflected ray, they lie in the same plane. So these are the law of reflection. And you see, whenever we are discussing the regular reflection and diffused reflection, this law is always valid. It appears that this law is valid only for the smooth surfaces. Angle I is equal to angle R only for the smooth surfaces. No, this law, the law of reflection, is universe. It is valid for smooth surface as well as for the rough surface. And whenever you're doing spherical mirrors or plane mirrors, you are doing ray formations, ray diagrams, this law is valid, and you have to follow only this law for making the ray diagrams, for doing your numericals, and even for the sign conventions also, where to take positive sign, where to take negative sign. So this law of reflection is always valid, and we need to follow this law only for doing various activities and various numericals and various other topics of the chapter. So I am going to deal with the first law of reflection only, and the sign conventions and ray diagrams related to the spherical mirrors. So in this particular lecture, I will discuss sign conventions and formation of the ray diagrams. Okay students, so let us discuss some of the basic terms used in this chapter. So reflection, this is what are the laws of reflection. Angle of incidence is equal to angle of reflection, and incident ray, normal and reflected ray, they lie in the same plane. And law of reflection is valid for every surface, whether it is rough or smooth. Law of reflection would be satisfied. And now coming directly to the spherical mirrors, we have two types of spherical mirrors. One is, this is the convex mirror, and this is concave mirror. So here, this surface, this is the reflecting surface. So this is away, outside. And you see the spherical mirrors, why they are called spherical mirrors? Because they are the part of a sphere. This is also the part of the sphere. So in this particular case, the reflecting surface is towards the center of the sphere, and here the reflecting surface is away from the center of the sphere. Now, some of the terms which we use for the spherical surfaces, this point which divides the sphere, a spherical mirror, into two equal parts, this is called pole. This is center of curvature. Basically, this is what? This is the center of the sphere from which you have made this spherical mirror. Similarly, you can see here center of curvature is lying behind the mirror in case of convex mirror, and here in this particular case center of curvature is lying in front of the mirror in case of concave mirror. And this is what? This is the radius of the sphere. So similarly, this, for if you want to define radius of curvature here, this is the same radius. This is same radius. So basically, the point on the mirror which is joining, so the point and the center, the line joining the point on the mirror and with the center of curvature is the radius of curvature, or in other words we can say this is the radius of the sphere from which you have made this spherical mirror. So similarly here, radius of curvature is this line which is joining any point on the mirror with the center of curvature. So this is the radius of curvature. Next is focus. What is focus? Focus is what? You see, when parallel beam of light is going to incident on the mirror, then it will converge at a point, or it will appear to converge at one point. So the point is called focus. So here let us consider example of concave mirror. If this is concave mirror, in this particular case, when the parallel beam of light is coming, this is the principal axis which is passing through the pole, and you see after striking with the mirror, these rays are going to converge at one point, and the point where these rays are going to converge is called focus. And if this is a convex mirror, then these lines, parallel lines, they will not converge at this point because they are going to diverge in this direction. So you will extend them in the backward direction. So these are the directions of the rays. So here actually rays are not going to meet, but when you are extending them in the backward direction, so in that case you will get one point where the two rays appear to meet. So this point is called focus. And here in this case you can see, in case of concave mirror, the focus is lying in front of the mirror, and in case of convex mirror, focus is lying behind the mirror. Their focus is lying behind the mirror. I will explain it later. Why in case of concave mirror the rays have bent towards the principal axis, and why in case of convex mirror they have gone away from the principal axis. The magic is just the law of reflection. We'll discuss it later. Now, the distance between the pole and focus is the focal length, and here you can see focal length is this much distance, and similarly here focal length is PF. So here you can see focus was lying in front of the mirror in case of concave mirror, and focus is lying behind the mirror in case of convex mirror.